Thank you, everyone. So, a lot of information in a few slides. Let's try to get through this. So anyways, I'm at the University of Texas at Austin. I do this thing called space situational awareness, which is really decision-making science for things in space. Let's talk about some of the problems a little bit. So, near-Earth space, meaning things around Earth orbit that don't go all the way out to the moon. We can say that space is contested both geopolitically and commercially. Geopolitically, we have Space Force. We see that France now has some sort of defense-related activity that, towards space. We see more and more governments trying to build up this sort of space defense security capability. And then commercially, right now, and I'm going to actually show you how many human-made objects are being currently tracked in space. More and more companies see this bonanza. It's like a gold rush. They see that there's a lot of money to be made in space, and they're trying to put as many satellites on orbit as quickly as possible to try to capitalize on that. The other thing, too, is we have this thing called the Outer Space Treaty, which some of you may have heard of. And one of the things that it speaks of is this idea of continuous monitoring and supervision. And I'll say that nobody does that well, okay? Nobody does this continuous monitoring and supervision of all this stuff in space. And the last thing is that even though space could be thought of as being infinite, near-Earth space is finite. We don't put things just anywhere in orbit, and so that needs to be protected environmentally. And so I was able to speak with Al Gore at the TED conference in Vancouver in April, and he was unprepared for some of my questions. But in any case, people say, well, space debris and that's not climate change. Well, I didn't say it was. What I'm saying is that it needs to be protected as an environment, but a lot of people use climate change and environmental protection interchangeably, and they don't necessarily mean the same thing. All right. So, there are a number of services and activities that we leverage that are space-based. Everything from position, navigation, timing. A lot of financial transactions, banking are stamped with timing from space-based systems like Global Positioning System and Galileo and others. You have agriculture. You have communications, TV. Soon the internet itself is going to be space-based. And there's nothing protecting any of these services from not working at any given instant in time, okay? So that's an issue. We talk about managing that domain, but one of the things that I say is you can't manage what you don't know, and you don't know what you don't measure, so it all comes down to measurements. People want to know, what is normal behavior in space? Anybody in this audience think that they know the answer to that? Please raise your hand right now, because I need okay. I don't see any hands being raised. So we don't know what normal behavior in space really means. One of the bad things about space situational awareness is that given a body of evidence, usually multiple hypotheses, multiple possible causes explain the same evidence, and these possible causes can be extremely different from each other. Everything from maybe the sun had a hiccup of energy to maybe Jimmy doesn't like me so much and he did something with his satellite to my satellite which disabled one of my services. So it's just, there's a lot of ambiguity, okay? There's a lack of transparency in space operations. The largest database, publicly available database of objects in space is owned and operated by the US military. So when it comes to transparent organizations, I'm gonna tell you that one's not one of them at the top of my list. And then one of the things that people are very concerned about is this kind of Shakespearean thing that I like to say, debris or not debris? That is the question, okay? So out of everything up there, what do I really have to be concerned about? So I made this Venn diagram just to kind of explain things just a little bit. I won't spend too much time here, except to say we have the set of all events that occur in outer space. That set as a whole is not knowable. We can't know everything. So there's a subset of things that we believe, okay? And then there's another subset of things that we measure. And whenever these things coincide, that's the knowledge, actual knowledge that we have. But not everything that we believe, so some of you might be making fun of me, say, oh, well, this guy, he can't get his circles to line up with each other. So The reason why the belief circle extends outside is because we actually believe things that are physically impossible. So all our beliefs are not actually true. And when it comes to information sources are biased, and sometimes sensors report things that are actually not true either. So we have to live in that world where part of what we have to deal with is physically impossible for it to happen. Here's an example of some anomalies that I was talking about, trying to distinguish. Halloween 2003, there was this kind of storm, and several satellites experienced some anomalies. So, some people thought, well, maybe it could be a cyber attack, and maybe it's not the natural space environment. Some people thought, well, maybe somebody's jamming my signal. It's not the sun, and so on and so forth. So it's very difficult to attribute cause to these anomalies, especially when we don't openly share all the information that's happening, okay? So one of the things that we developed at the University of Texas is this thing called Astrograph. You can actually Google this stuff and see it on your phone. But this is a combination, it's the world's first crowdsourced space traffic monitoring system that combines multiple sources of information and just plots all this stuff at once. So all of those dots, which are not to scale, I want to say that, so don't get too scared. So it's notional. But all of these dots are human-made objects in space, okay, right now. And this gets updated every 24 hours on its own. But back to lack of sharing of information, we make a lot of decisions based on incomplete data, okay? And we want to complete it. We get some measurements and then we make assumptions. And we get into trouble when our assumptions exceed the actual information set that we have. And so, to give you an idea of how bad this can be, you go, okay, this is a nice cartoon, but really, I mean, when it comes to space, give me an example of where you can see this. Here we go. So if I look at the US public catalog from the US Department of Defense, this is what the space traffic map looks like right now, okay? Looking down on the geobelt on Earth, those are all the human-made objects that I can get publicly. That's the map that I get when I query the Russian database. They don't look the same, okay? They don't overlap much. This is what I'm telling you is part of the problem, is that the truth from two different sources is drastically different from each other. And what we need to do is we need to have a way to independently combine all these opinions to come up with what is truer. That's what we need to do. How do you know that you have the world's most accurate clock? Anybody have a clue in this room? Anybody have an idea? How do you know you have the world's most accurate clock? The reason is you have hundreds of them. That's how you know. So that's how we tell time today in the world. We have hundreds of atomic clocks spread all over the globe. Each of these clocks has an opinion, and the weighted combination of these opinions is the actual timing standard that we have from one day to the next. This is the importance of crowdsourcing information, is that you don't let any single source dominate or completely bias your perspective of what's happening. You want to be independent of that. And so the thing is, if you can get a lot of information from independent sources, you tend to see consistency and inconsistency, okay? Here's actual data from a sensor called the Space Surveillance Telescope. It's actually in Australia right now. Now, the good thing about the Space Surveillance Telescope is that it detects lots of things. The bad thing about the Space Surveillance Telescope is that it detects lots of things. So what I'm telling you is this. All of those dots are detections, okay? A single night's worth of detections. All of the dots that are black are things that we believe we know and everything else is unknown. Every night, this is what gets produced. So there is a background of clutter of unknown stuff that we have no idea if it's a threat, if it's a hazard, what orbit is it exactly in, none of that stuff. So that's the difference between just detecting things and tracking. Tracking is detecting and identifying. You have to be able to do both. Detecting is just, there you go, detections. So we have an identity crisis in space. Most of the objects in space don't self-report their identity or their location. So what we have is, we have different times when we collect data, these dots are just whatever, they're not self-reporting, and so we need to get to task to identify all these things. Can we put a first and last name to all these objects in space? We'd love to start way on the left with things that we actually measure, and then we'd like to move to the right to see how we can uniquely identify objects. So one of the things that I tell my students is, if you want to know something, you have to measure it, and if you want to understand something, you have to be able to predict it, okay? we're in trouble in the sense that we're massively launching stuff on orbit. This is just planned launches in the next few years by just a couple of, SpaceX, Blue Origin, we have Amazon's Kuiper constellation, we have the Starlinks. So this is just, US-based stuff. I guess OneWeb is more Intelsat and whatnot, but most of that is US companies. So our current catalog is about 26,000 objects, the size of a cell phone all the way to a school bus. We're planning on launching 15,000 more objects just in the next few years, almost doubling the current size of what's tracked, okay? This gives you an idea of the locations, orbital altitude, and number of objects. These things aren't uniformly scattered. They're going to be sharing real estate, okay? And we got no space traffic rules. Behaviors that enable safety, security, and sustainability, we get there through transparency and predictability, but predicting behavior isn't just about physics. We have the UN long-term sustainability guidelines. 21 of these things got adopted. Guess what? If people have to implement that right now, do you think they're going to implement that all the same way? What is Sharia interpretation of the guidelines? What is the Jewish community going to do about that? How are Americans going to implement the guidelines? So even though we agreed on the guidelines, the implementation is not necessarily going to be uniform and standard. So one of the things that we want way ahead, try to make everything as trackable as possible. We want to bring in, social scientists. We want to bring in anthropologists because we actually need to understand people a little bit better because the space domain is an extension of human activity. We actually need to monitor the population, crowdsource. Don't let any single source of information dominate or bias or prejudice our idea of what's going on in space. And we really need to do this through international partnership. Thank you very much.